Okay, going to look at question 10 with a triangle. Just quickly going to put the information down. I've got a minus 2, a plus 1, and a, angle sigma, angle pi on 3, and p, q, r. So, part 1. Part 1 asks me to show that a equals to 7. So, I'm interested in three sides of a triangle and I've got an angle. So I'm going to use the cosine rule. I'm going to jot that down. A squared is b squared plus c squared minus 2bc cos A. I've just got to make sure that the angle matches the side that I use here. So the angle is going to be this one. So I'm going to start off with a squared, this side, is equal to then the other two sides. So a minus 2 all squared plus a plus 1 all squared minus 2, same sides again, so a minus 2, a plus 1 times cos pi on 3. So let's start to tidy this up a little bit. This is going to be a squared minus 4a plus 4 plus a squared plus 2a plus 1 minus 2 lots of a squared plus a minus 2a is minus a minus 2. And then I need to figure out this cos pi on 3. So let's draw my useful triangle. Hypotenuse 2, that side 1, that's pi on 3, or 60. That's root 3. So cos of this angle, adjacent on hypotenuse, I know that's a half. So I can now start to tidy this up a little bit more. Let's work this out. That's going to be 2a squareds here, 2a squareds, minus 4a plus 2a is minus 2a, plus 4 plus 1 is plus 5. That 2 gets cancelled with that, leaving me with minus a squared, plus a plus 2, that's a squared. Keep tidying up. 2a squared minus a squared is a squared, disappears with that one. So my a squareds all cancel out. Minus 2a plus a is minus a. Bring that over here. A equals 5 plus 2 is 7. So I've done that as required. That's part 1 done. Part 2 asks me to show that the sine of sigma is equal to something. Well, now I'm going to go to the sine rule. I know that sine of the angle I want over its corresponding side, a plus 1, a is 7, so that's 8, is equal to sine of this one, sine of pi on 3 over its corresponding side, which is 7. I'm going to use my triangle to get sine pi on 3. Sine pi on 3 is opposite on hypotenuse, is root 3 on 2, so I can tidy this up. Sine sigma, 8 times root 3 on 2 and divided by 7 or times 1/7 gives me, make sure this works, 8 over 2 is the 4, root 3 on 7 as required. So I've got that done. Moving on to part 3. Asks me now to find cos 2 sigma. Cos 2 sigma. I've got choices here. I know that that could be cos squared minus sine squared. I know it could be 2 cos squared minus 1 or 1 minus 2 sine squared. I might as well use this one because I've got sine sitting here ready to use. So I'm going to use 1 minus 2 sine squared sigma. So it's 1 minus 2 lots of, let's square this, 16 times 3 on 49. Let's work this out. 2 16s are 32 times 3, 96. So it's 1 minus 96 on 49. So that's 49 minus 96 on 49. That turns out to be, I need to do a bit of arithmetic there, that's minus 47 on 49. So that's answered there. So that's part A done. Let's move on to part B. Make sure you've got my paper in the right place. Part B. Gives me a function, function of x. Let's jot this down. Cos x 1 plus tan x times cos x minus sine x, making sure I copy that down carefully. And part 1 asks me to show that it equals something else. So I'm going to set up the right hand side equals, and hopefully it's going to end up being cos 2x. Coses and sines, so I'm going to swap that. So let's go cos x 1 plus sine x over cos x. Let's leave these as they are, cos x minus sine x. I'm going to cross multiply to get that over a common denominator. Cos x is going to be cos x plus sine x then over cos x. You can probably see where this is going, minus sine x. The coses here will cancel, and this leaves me then this these two brackets to multiply. And I've got cos x times cos x is cos squared x. Cos times minus sine, and then cos times sine will disappear, leaving me then with the last term of sine times minus sine of minus sine squared x. And that actually matches one of the formulas I spotted before. That is what I need for cos 2x, equals left hand side as required. So that's that result shown. Part 2. Hence, or otherwise, solve f of x equals 0. Well, I know f of x is this. So the question is now asking me to solve cos 2x equals 0. Well, let's think if cos of something is 0, let me just sketch the cos curve. I know that's pi there. Where is it 0? It's 0 at pi on 2, again at 3 pi on 2, and there would be more. I can put more on if I need to. That's 2x, of course. I need x, so x is going to be pi on 4. Divide this one, 3 pi on 4, and there'll be more. I need to check the domain of the question. The question said that x is between 0 and pi on 2. So I didn't need to worry about any negative ones. This one is fine. This one is past the domain that I need, so that's not applicable, and I've just got x is pi on 4. So there's my solution to part 2. Part 3 gives me a further sketch. Okay, so I've got this curve which is root f of x, and I'm asked to find the area, or the volume, once this area, pi on 8 to 0, is rotated. And I know that the volume of a rotated figure is given by pi times the integral of y squared with respect to x. So let's start to put in what I know. Pi can just sit at the front. My limits are pi on 8 and 0. Y squared, so I need that squared. Well, conveniently, the question's got it square rooted, so it's going to be just f of x, which I know is cos 2x. So the question becomes this. I've got to integrate cos 2x. I always remember sine cos minus sine minus cos. To differentiate, I go that way. To integrate, I go this way. So cos integrates to sine. So pi, square brackets, sine 2x, but also the 2 means that I need a factor of a half there. Pi on 8 and 0. Now I need to substitute in. I can pull this half out just to keep it out of the way. So pi on 2, let's go sine 2x. If x is pi on 8, then that's pi on 4 minus sine of 0. And I'm almost there. Pi on 2 sine pi on 4. If I need to sketch a triangle to get that, I know pi on 4 triangles 1, 1, root 2. So now sine of pi on 4 is 1 on root 2. Sine of 0, I know it's 0. So I've got this answer. I'd like to rationalise it by making sure I've got no square roots on the bottom. So times this by root 2 on root 2. see what we get. On the top, I've got root 2 pi. On the bottom, I've got 2 times, there's another 2 there, so I've got root 2 pi on 4 as my final answer.